Good morning, students. In the last class, we learned regarding the chemical reactions and equations, and we also defined those terms. So, chemical reaction is nothing but it is the process in which new substance is formed. Then what is that new substance? Means how it is called as new substance? Yes, we know that with new chemical as well as physical properties. Now let us understand what you mean by chemical equation. So as I defined in the last session, it is nothing but a shortcut way of writing a chemical reaction is called as chemical equation. But the shortcut way means we can't write it whatever or however we want it. Okay, so it has some rules. So today's session we are going to learn in detail regarding how to write the chemical equation, what all we should write, which side we should write, and what the other symbols or the conditions indicates. Okay, and certain symbols of certain elements also we are going to learn later. We are also going to learn regarding balanced chemical equation. Okay, now here the first, it is nothing but a chemical reactions and equations. The topic is chemical reactions and equations. So today's sub concept is writing chemical equation. Writing chemical equation. Okay. Now, so when I say chemical equation, we know it is a symbolic representation. And when I say chemical reaction, we know that in chemical reaction, we should be having the substances like reactants, and we should get a new substance which is called as product. So where we have to write the reactants, where we have to write the products. Okay, let us consider an example of formation of ammonia. So here, formation of ammonia. Ammonia is made up of formation of ammonia. So ammonia is formed, okay, chemically in the laboratory by combining two gases, that is nitrogen plus hydrogen gives us ammonia. So what I wrote here, it is also a chemical reaction. As I wrote in the form of words, this is word equation. So I wrote now word chemical equation of formation of ammonia. Let us write the symbolic equation. Okay. So for symbolic equation, it is very necessary to know the symbols of all the elements, at least for 10th standard. Okay. Memorize the symbols of the elements at least until atomic number 30. Starting 30 elements, you should know the symbols of the chemicals. Okay, next symbolic equation. So nitrogen is represented by N2, hydrogen is represented by H2. So the product formed is NH3. NH3. So when you see here, what combined, which elements combined, means which reacted to one another, those are written as or on the LHS side, that is left hand side. But for the new substance which is formed should be written on RHS side. So what we have to write on LHS side, that we have to write reactants on LHS side. Same way we have to write products on RHS side. And the arrow mark indicates the formation of the products. Okay, and also it is used to indicate or write certain conditions. Okay, now let us take an example of photosynthesis. Okay, So I did not write any balanced equation here, because as I am going to deal with the how to deal or how to write a balanced chemical equation, I just wrote skeletal, that is unbalanced equations. So let me balance it here. 2, here it is 3. Now, so photosynthesis reaction. Okay, in photosynthesis what happens? Let us write directly the symbolic equation. Carbon dioxide reacts with water in presence of sunlight. So the condition should be written above and below the arrow mark. To show that, I gave you an example of photosynthesis. Sunlight and chlorophyll. Okay. So when they react, it will give C6H12O6 plus O2. Okay. And sometimes we will also write plus H2O, which will break down later, immediately after the photosynthesis reaction. So this is regarding how to write the chemical equation. So 3 points we should remember. Reactant should be written on left hand side. Product should be written on right hand side. Arrow mark indicates formation of new products and the conditions for a reaction. For example, sunlight, heat, electricity should be written above and below the arrow mark. Okay. Now, and we should also write the physical states of reactants. Physical state means whether the reactant is in a solid form, is in a liquid or a gaseous form. That also we have to write. Then, and the physical state of product also we should write. Why we should write? We know that if any chemical reaction has to take place, how we will get to know chemical reaction is taken place? The color may change, the odor, the smell may change, the physical state as well as the chemical property may change, the appearance may change. That is why to confirm it, to know it, we should write the physical states. So what are physical states? These are nothing but physical states means solid, liquid and gas. So nitrogen will be in a gaseous form, hydrogen will be in a gaseous form. Whatever ammonia we will get, it will be in a liquid form. Same how carbon dioxide is gaseous, water will be in a liquid form. This will be in a, usually it will be in a liquid form which will be dissolved in a water, and this will be in a gaseous form. This is also in a liquid form. So like this, we have to be careful while writing the chemical equations, and we have to take care of these rules. Next one. Whenever you go to the market or your mother says you to buy 1 kg of tomato, 1 kg of potato, 2 kg etc. So that time you might observe the vegetable vendor, the shopkeeper. So what he will use? He will use the measurement, the weighing machine. So how you will observe whether he is measuring correctly? So he will put a required amount of that stone in one plate. In the other plate he will put, let us take a tomato. So when the needle comes at a center, then he will say it is 1 kg of tomato. Okay, so what happens? What should happen there? On both plates, the both plates should be in a same plane and the needle should come in a center. Okay, like that, in the chemical equation also, what are the elements, what are the atoms of an elements which will combine, which will react together, okay, they will give certain products. So the number of atoms on the right hand side, on the left hand side, the number of atoms of the same element on the right hand side should be equal. This is nothing but the mathematics in the chemical equation. So according to the mathematics, what we know, the LHS should be always equal to RHS. Left hand side values should be always equal to right hand side. Like that only, in chemical equation, the number of atoms on the right hand side of a particular element should be equal to the number of atoms on the right hand side of a particular element. Let me explain you using this example now. See, nitrogen is 2 here. Okay. It was not there before. When the reaction happened, it was NH3. So here nitrogen is 2. Here nitrogen is 1. So to make it equal, what I wrote 2 here as a coefficient. I did not write as a subscript. This is not allowed. We can only write as a coefficient. Means before that element, atoms or atom of an element. Okay. So 2 when I write here, it will become 2n. Means nitrogen will become 2 atoms. Here also nitrogen is 2 atoms. Next. Before here only H2 was there. But here H3 is there. So both are not balanced. And when I wrote 2, the hydrogen atoms 2 into 3, we have to multiply the upper number to the lower number. Coefficient to the lower number. 2 into 3. So the hydrogen became 6. Okay. So 6 atoms are there. Here 2 atoms are there. So I want to make it to 6. So what I am going to do? I am multiplying it with the 3. So 3 into 2 is 6. 2 into 3 is 6. Hydrogen is 6. Hydrogen is 6. Nitrogen is 2. Nitrogen is 2. Now we can say this chemical equation is balanced. Let us study the step-by-step procedure of a chemical equation. How to balance it now. But to ensure you, to continue with the explanation, I just explained you this. Now let us take the other example. So the next concept we are going to learn is balancing chemical equation. Okay, balancing chemical equation. So this balancing chemical equation has several steps in it. Okay, so let us take an example of water, formation of water. Let us proceed from easy to tough one. Formation of water. Okay, formation of water. So in the formation of water, we know that the reactants are hydrogen plus oxygen gives us H2O. Hydrogen plus oxygen gives us H2O. So let us name LHS and RHS. This is a LHS side, this is RHS side. So these are reactants. This side is a reactants and H2O, water, is a product. Okay. Then now we have to balance. For that, what is the first step? First, we have to note down which are the atoms of elements present on the left hand side. So when you see, as this is a very simple equation, so we have only 2 atoms of elements, 1 atom, 2 atoms of hydrogen, 2 atoms of oxygen. So let us write H, let us write O. H is 2 here, O is 2 here. This is the second step. Similarly, product side, when you write H, when you write O, H is 2 here, oxygen is 1 here. So when you compare both sides, hydrogen number, that is the number of atoms of hydrogen are equal to 2. But when you see the oxygen is 2 here, the oxygen atom is 1 here. So to balance it, what I am doing, I am writing 2 here. I am writing 2. So when I write 2 here, 2 into O. 2 into O, that is 2O. So it became 2. Okay, oxygen became 2. Similarly, but the hydrogen changed here. 2O. Good, balanced. But when you see the hydrogen, the number of hydrogen here will be 2 into 2. 2 into 2. So it became 4. Now the hydrogen is unbalanced. So to balance it again, I am writing 2 here. When you write 2, you can see 2 into 2. So it also became 4. Okay. So when you see the left hand side and the right hand side, just check. Hydrogen 4, hydrogen 4. Check. Oxygen 2, oxygen 2. Check. Like this, we have to balance the equation. This is a detailed procedure of balancing chemical equation. But when you learn or when you practice more examples, these steps are not needed. You can balance like directly in the equation itself. But for that, you have to practice more equations. Fine. Now, let us take an example of a photosynthesis itself. So, carbon dioxide plus water gives us simple equation we will consider, that is glucose plus oxygen. We will not consider water which will photolysis later. That reaction I will handle later. Okay. Now let us take this simple equation of photosynthesis. So here let us mark as LHS and let us mark as RHS. So what will be there on the left hand side? Yes. Yes, your assumption or your guess is right. We will be having the reactants on the left hand side. We will be having products on the right hand side. Good. Now, let us consider which are the atoms present on left hand side. So, we have carbon C, we have oxygen O, we have hydrogen. Okay. When you see the number of carbon atoms here, it is nothing but 1. If nothing is there here, it will be 1. So, 1. Oxygen 2. Okay. Then oxygen 2 plus 1. 2 plus 1, it will be 3. So, oxygen will be 3. Next, hydrogen H2. Hydrogen will be 2. Same way, in the product side, carbon, oxygen and hydrogen we have. When you see the number of atoms of carbon here, it is 6. The number of atoms of oxygen, 6 plus 2. 6 plus 2. So it is 8. Fine. The number of atoms of hydrogen is 12. So there is a lot of difference on LHS and RHS of all the atoms, of all the number of atoms. Let us balance. So here it is 1, here it is 6. I want 6 here. So what I am going to do? I am writing 6. I am writing 6. So 6C. So here the number of atoms of carbon became 6. But one more atom changed, that is oxygen. 6 2s are 12. 12 plus 1, 13. It became 13. Right? Next. Let us consider hydrogen now. So H12 is there, H2 is there. H12 is there, H2 is there. So I am writing here. I want to make this as 12. So what I have to multiply? To how much is that 12? We should think over. Yes? Yes. So it is nothing but 6. So 6 2s are 12. So here the atoms became 12 and hydrogen atoms got balanced. Now 6O, 6 2s are 12 plus 6O, that is 6. 12 plus 6. So this became 18. Oxygen became 18 now. But here only 8 is there. Okay. So this is 6. I can't write 3. If I write 3 here, 3 6 are 18 plus 2, 20. It will become 20. So what I am going to do? I am writing 6 here. When I write 6 here, 6 twos are 12 plus 6. 6 twos are 12 plus 6. It will be 18. Okay. So when you observe the number of atoms on LHS and RHS, carbon 6, carbon 6. Check. Right? Then oxygen 18, oxygen 18. Check. Hydrogen 12, hydrogen 12. Check. This is how we have to balance the chemical equation. So first you practice writing the chemical equation step by step. Later when you solve more than at least 30 examples, then there is no need to write these steps. You can write directly or balance directly in the reactions or an equation itself. Okay. I hope the concept of writing chemical equation and balancing chemical equation is clear for everyone. In the next session, we are going to deal with more examples of balancing chemical equation, and also we will just briefly study about the types of reactions. Until that, take care. Have a nice day.